I'm going to compare three popular ways to wire batteries in parallel. We'll look at the advantages of each method, the cost differences, and a few important mistakes that can cause problems if they're overlooked. By the end of this video, you'll have a much better idea of which wiring method makes the most sense for your own battery bank. Before we compare the different layouts, there are three important things you should know. The first one is that every battery connected in parallel should have its own fuse. Here's why this matters. If one battery develops an internal short circuit or another serious fault, the remaining batteries can instantly feed a huge amount of current into that failed battery. Without individual fuses, that fault current can become extremely dangerous and may damage cables, battery terminals, or even start a fire. Adding a fuse to each battery helps isolate a fault before it can affect the rest of the battery bank. It's one of the simplest safety upgrades you can make. The second point is for anyone building a 24-volt or 48-volt battery system. Whenever possible, use batteries that are already designed for your system voltage. For example, if you're building a 48-volt system, choose 48-volt batteries instead of connecting several 12-volt batteries in series. The reason is simple. When batteries are connected in series, they don't automatically stay balanced with each other. Over time, differences between the batteries can grow, which often means you'll need battery balancers or additional equipment to keep everything operating correctly. Parallel batteries behave differently. Because they're connected directly together, they naturally equalize their voltage, making the system much simpler to manage. That's one reason many installers prefer parallel battery banks whenever it's practical. One extra tip worth mentioning is that using batteries from the same manufacturer with the same capacity and a similar age usually gives the most balanced performance over the long term. While mixed batteries can work in some situations, matching them as closely as possible is always the better choice. The third thing many people ask is whether batteries with different capacities can be connected in parallel. The answer is yes. For example, you could connect one 12-volt 100 amp-hour battery together with one 12-volt 200 amp-hour battery. The larger battery won't force the smaller one to become a 200 amp-hour battery. Instead, each battery simply contributes current based on its own capacity and internal resistance. Now that we've covered those important basics, let's look at the first parallel wiring method. This is probably the simplest approach, especially if you're only connecting 2 or 3 batteries. With this setup, an MRBF fuse is mounted directly onto the positive terminal of each battery. From there, each battery is connected individually to the main bus bars using its own cable. It's a very clean layout, it's easy to understand, and troubleshooting is usually straightforward because every battery has its own dedicated connection. To help the batteries share the load more evenly, it's good practice to take the main positive connection from the first battery and the main negative connection from the last battery. This encourages a more balanced current flow across the battery bank instead of placing more demand on just one battery. The biggest drawback of this method is the cost. Since every battery connects directly to the main bus bars, each cable normally needs to be sized for the maximum current that battery could deliver. On top of that, MRBF fuses and their terminal blocks are generally more expensive than many other fuse options. If you want an easy way to disconnect the entire battery bank for maintenance, you can also install a main direct current breaker between the batteries and the system bus bar. That gives you a single switch to isolate the battery bank whenever you need to work on the system. Just remember that this main breaker or fuse must be rated to safely interrupt the maximum fault current that the complete battery bank could produce, not just the current from a single battery. Now let's move on to the second method. Instead of using separate cables all the way to the main bus bars, each battery connects to a single mega-fuse bus bar. Your inverter, charge controller, and the batteries all connect to this same fused bus bar. One of the biggest advantages of this design is cost. Because each battery branch only carries the current from that individual battery, you can often use smaller cables for those connections. Mega fuses are also usually less expensive than MRBF fuses, making this setup much more budget-friendly. For a system with only 2 or 3 batteries, it's difficult to beat this option in terms of value. The downside is expansion. A typical mega fuse busbar has 5 fuse positions. One position is commonly used for the inverter, another for the charge controller, leaving only 3 positions available for batteries. If you later decide to add another battery or another device, such as a battery charger, DC power supply, or another high-current load, you'll probably need to install an additional fuse block or redesign part of the system. Another thing to keep in mind is that this arrangement usually doesn't include a single disconnect switch for the entire battery bank. If that's something you want, you'll need to add a properly rated breaker or battery disconnect separately. Now let's look at the third wiring method, which is generally the better choice once your battery bank starts growing. The third method is designed for larger battery banks and works especially well when you have more than 3 batteries connected in parallel. In this setup, all of the batteries connect to a dedicated battery busbar first. Then, a single heavy-duty cable connects that battery busbar to the main system busbar. This keeps the wiring much cleaner, makes future upgrades easier, and gives you plenty of room if you decide to expand your battery bank later. Of course, because that main cable carries the combined current from all of the batteries, it must be protected with the correct overcurrent device. That could be a properly rated direct current breaker, a Class T fuse, or an NH0 fuse, depending on your system design and the fault current you're expecting. This layout follows the same basic idea used in many professional battery distribution systems. The difference is that you can often build a very similar arrangement using standard bus bars and fuse blocks for much less money. Now let's compare the cost of all 3 methods. For a system using 3 batteries and a 3,000-watt inverter, the numbers look like this. The first setup, using MRBF fuses on each battery, comes in at around $278. The second setup, using a single mega fuse busbar, costs about $118. The third setup, with separate battery and system busbars, comes to approximately $234. So if you're only planning to run 2 or 3 batteries, the second method offers the lowest cost. However, if you know you'll be adding more batteries in the future, spending a little more on the third layout can save both time and effort later, because it's much easier to expand. One thing I haven't covered in detail here is cable sizing and fuse selection. Those topics depend on factors like cable length, maximum current, voltage drop, and the equipment you're using. They're important enough to deserve their own dedicated discussion rather than trying to squeeze everything into one video. Before we wrap up, here are a few extra tips that can make your installation even better. If you're only connecting 2 batteries with MRBF fuses, compact single-stud or double-stud busbars can reduce both cost and wiring clutter while keeping the installation neat. Also, avoid stacking too many cable lugs on one terminal. As a general rule, no more than 3 lugs should share a single stud, and always make sure the busbar itself is rated for the maximum current your system can deliver. Another thing worth checking is the mounting hole size on your MRBF fuse blocks. Many are designed with 10mm holes, while most lithium batteries use 8mm battery studs. Some manufacturers do offer 8mm versions, so it's worth confirming compatibility before ordering your parts. Now let's talk about one mistake that can become a serious safety issue. Many people install standard mega fuses in 48-volt battery systems without realizing those fuses are commonly rated for only 32 volts. That's a problem. A fuse isn't just about current, it also has a voltage rating, and if that rating is too low, the fuse may not safely interrupt the electrical arc during a fault. For a 48-volt battery bank, use protection that's specifically rated for the higher voltage. That could be a 70-volt mega fuse, an MRBF fuse, a Class T fuse, an NH0 fuse, or a battery breaker with an appropriate voltage rating. Always verify both the current rating and the voltage rating before installing any fuse. Finally, let's clear up one common myth. You've probably heard that every battery cable in a parallel bank has to be exactly the same length. In reality, having similar cable lengths does help the batteries share current more evenly, so it's definitely good practice. But don't get obsessed with making every cable identical down to the last inch. With a properly designed busbar system, small differences in cable length usually have very little impact on real-world performance. Focus on keeping the wiring neat, using the correct cable size, making solid crimp connections, and tightening every terminal to the manufacturer's recommended torque. So to quickly summarize, the first method is simple, reliable, and ideal for smaller battery banks, although it's also the most expensive. The second method gives you the lowest cost for systems with 2 or 3 batteries, but expansion is limited by the number of fuse positions available. And the third method is the best long-term solution if you're planning to build a larger battery bank because it's clean, organized, and much easier to expand in the future. I hope this comparison helped you understand the differences between these wiring methods and made it easier to decide which one fits your own solar system.